So good evening, everyone. So I welcome all of them to this free masterclass on GD&T. So geometrical dimension and tolerance. And this is session 4, Unlock the Languages of Engineering Drawings presented by Unique Measurement Services. So let me just explain you about the organizations. So Unique Measurement Services, the largest industrial measurement and calibrations, testing, scanning services provider in India. We were established in 2015, headquarters in Chennai. We operate 16 branches and we advanced measuring machines with the highly accuracy. High pressure and fully automated machines. We provide 24 by 7 house service provider for all India. So our inspections is like CM inspections, portable CMM, on-type on-site inspections, laser tracker inspections, calibrations, reverse engineering, metrology training, and courses. So I introduce our chief guest, Mr. Paraniappan Kailasan. So I welcome your chief guest. So he has 22 plus years of experience and he is the GD&T expert and he is the director of Management Tech Solutions. So as of now, till the date, he have trained 5,000 students engineering professions corporates in India, in Singapore, Malaysia, UK, US, Spain, and UAE. So instrumental motivating guidance and training and by engineering professionals in clearing ASME GDPT clarifications exams, both technologist and senior level. So till now, he have created 70 plus se- seminars and workshops and machine designing gigs and futures designings. So we have some different formats accordingly. So about our GD&T training programs, format in both online as well as the online and hybrid, and the minimum 15 hours to 40 hours the duration will be, and which includes the live sessions and practical examples and with the certifications to be offering them. So we are expecting the suitable for person for this session is the students and engineerings and QA professionals. So at the last sessions, we have gone accordingly like introduction about GD&T and why GD&T is important and basic concepts, futures control, fame, datum, and symbols. Tolerance of form, tolerance of orientations, tolerance of locations, tolerance of runout, tolerance of profiles. So I hope you people have understood about it. So I hope I have explained everything very clearly. So I hand over this sessions to Mr. Palaniappan Kailasan. Thank you.
Thank you, gentlemen, and hi all. Am I audible?
Yes, sir.
Very good. So, good evening to all of you, and I appreciate that being a weekend late night, most of you have joined to enrich your knowledge on GD&T. So, since already you had 3 sessions on GD&T with Tamil Parthi and team to have a basic knowledge and advanced knowledge on GD&T. I will just give you a recap of, according to me, what GD&T is in terms of engineering, manufacturing, and inspection. Then I would like to have this today's session as a more informal way of interacting with you people so that whatever doubts you have related to GD&T, I would be able to help you in clarifying those doubts so that today's takeaway would be on interaction on GD&T related doubts topics. Okay, so let me present a few slides to give you an overview of what I plan to present today. Yes. Hope my screen is visible to all of you.
Yes, sir, it is clear.
Very good. So I would be talking about GD&T related to engineering, manufacturing, and inspection. Already my introduction was given, so I will not spend much time about my introduction over here. One point what was not told by the introducer was that I am a senior certified professional from ASME USA. So I am certified in OI 14.5 2009 senior from ASME USA. So what is GD&T? Already people who are attending today would have definitely attended the previous three sessions. You would know what GD&T is. So according to me, GD&T is an international language in which we are going to describe three important aspects: size, form, orientation, and location of a part feature. Whatever part we are going to manufacture will have two dimensions. One is size, the other one is shape. So when we manufacture, we have to focus on controlling the size as well as shape. So these are the four parameters with which we will be able to control size and shape. So size, form, orientation, and location. So in this, you will see so few symbols. So GD&T is a language in which we will be using a lot of symbols and numbers so that people everywhere can read, write, and understand regardless of their native language. So this is one of such a symbol where you can get a description of how the hole should be located, right? Uh, as one of the session, Joshua introduced about GD&T and told that it was for developed by a person called as Parker in 1938, right? So, but if you remember, manufacturing do exist from 350, 400 years. So before 1938, what were they doing and what was the problem with that system? And why did we came to GD&T is what you should be knowing about. So earlier to GD&T, we were using a system called as coordinate dimensioning and tolerancing system. Many people call this as a CD&T, coordinate dimensioning and tolerancing. In this, if you see, compared to the previous drawing, this drawing and this drawing, the part is same, but the method of giving the dimensions are different. Here I have given this 15 with plus or minus 0.25 and this 10 plus or minus 0.25. So this method of dimensioning is called as coordinate dimensioning, where size dimension, location dimension, all the dimensions will have plus or minus tolerance. Having parts produced with this type of dimension we will be able to control the size, but we will not be able to control the shape. So if we want to control the shape, in addition to this, we have to add a few more requirements in the form of GD&T symbols. So here is one such example of a flange with all the dimensions having plus or minus tolerance. Okay, so if I give this to the fabricator, he may produce a part like this and give it to the inspector. Inspector will inspect each of those dimensions. These are the measured values. He will compare these measured values with the drawing specification. So here the drawing specification for the thickness is 0.815 plus or minus 0.005. After manufacturing, the inspector inspects this thickness. He finds 0.811, which is within the drawing spec. Like this, he will inspect all the dimensions and then he will think that the part is acceptable and he will accept the part. So uh, after accepting this part, it will go to the assembly. That is where the problem we're facing, the problem started in the olden days. So assembly mechanic will not be able to assemble this part. So he was the person who was checking whether the part will fit properly, function properly or not, and he was accepting the part or rejecting the part, which was taking a lot of time, efforts, and money for producing parts. To overcome this, the system was formed, which is nowadays being called as GD&T, geometric dimensioning and tolerancing. Why should we use GD&T? Now, in simple words, can anyone read this for me? Only people who know Chinese language would be able to read this. Now, today we are in a global village. The design would be done by Germans, and we would be sitting here and then producing the manufacturing drawings. It might get manufactured here, or it might be getting manufactured in China or Taiwan, and it would get assembled over there. And finally, the assembled product would go to America for use. So in this case, we are having cross-functional team with cross-functional geographical regions communicating about the product. So if language becomes a barrier, it would become very difficult. Now, instead of this language, if I use symbol, you go to any part of the world, and if you see the symbol, you will easily know what it means. Is it not? So this is the reason why we have to use GD&T. We are going to use some symbols which is globally accepted so that we can communicate our requirements to each other, and we produce a product which is usable, economical, and of good quality. Right? So for this reason, we require GD&T. So when we optimistically use GD&T, we can ensure that the parts will fit properly and function properly. It will reduce the risk of defects and rework. It improves the efficiency of the design and manufacturing processes. Because of these reasons, the product which are produced would have a lower cost. Okay. Now, whenever we talk about GD&T, there is a myth telling that GD&T is too complex and difficult to learn. Now, with the previous three sessions which you would have attended, you would come to know that when we follow the certain steps, then understanding GD&T is not at all difficult. Then once you understand GD&T, it would become a child's play, right? So GD&T is not at all complex. It is as good as any other language. Now in English, we had 26 alphabets. Then we started using those alphabets to form words. Then with that words, we started using sentences and we started communicating. Similarly, in GD&T, we have set of symbols. When we know how to put those symbols together, then understanding would become easier, right? Then the second myth many people think of is that GD&T is only needed for high precision applications. It is not so. Even for simple parts, if we use GD&T, we can reduce the cost of manufacturing. In one of the session, when Joshua was explaining about the position tolerance, he took a part with two holes. He gave positional tolerance and he explained to you what would happen if you don't give positional tolerance, and if you give coordinate dimensioning system, what would happen, right? That rectangular block with the two holes was a very simple part. But when we use GD&T, we take advantage of the tolerances and we can reduce the cost of manufacturing. So whether the part is simple, complex, or very complex, when we use GD&T, we can control the four parameters which I already told you: size, form, orientation, and location. And you will be able to produce parts which are of good quality, assemble them for your functional requirement, and reduce the cost for the organization. Many people think that if there are so many GD&T symbols, then the part is very critical, the tolerances are very tighter. But when you go deep dive into understanding of GD&T, you will understand that using GD&T optimistically will give you more tolerance for manufacturing. We will, so in one of the example, I think both Tamil Parthi and Joshua told that when you use GD&T, you will get a circular tolerance zone instead of rectangular tolerance zone, and you will get 57% more tolerance, right? So when you get 57% more tolerance, then it is no longer tighter. One thing. Second thing is, since we are giving more tolerance for the manufacturer and for the inspector, the inspection manufacturing method would also become easier, and inspection method would also become easier, so that cost will reduce. So if we give GD&T, having tighter tolerance or increased cost is a total myth. In many, I have been giving training for many companies, most of the MNC companies. So whenever I go there for training, if I tell the advantages of using GD&T, people over there would tell me that we can give GD&T, but what if our suppliers don't understand GD&T, right? Now, there are many cases where I have seen suppliers being more educated and more skillful in GD&T than the OEMs. So many of them are aware of the advantages of GD&T. Even small suppliers are nowadays learning this language, and then they are using GD&T in a better way. So I have just given you an overview of, according to me, what GD&T is, why we require GD&T, and I have clarified few of the myths. Now, UMS team, shall we open the forum for Q&A?
Yes, sir.
Yeah. Can we have the first question? I don't see any question in the chat box. Anyone from the audience, if you want to ask a question, if you find difficulty in typing the question, you can unmute and ask if you're allowed to unmute. Okay, so I have one question from Radha Krishnan. ASME 2009 versus 2018. What is the update? There are few significant updates compared to 2009 and 2018. The very first and important update is in 2019 standards, we have 14 symbols. That is what was explained by Joshua in the previous sessions. So we have 14 symbols. But in 2018 standard, we have only 12 symbols. Concentricity and symmetricity are deleted. So under location control, we have only one symbol, which is called as position. So we have 12 symbols, 5 categories in 2018. This is one of the important change. Another important change, what you can see in 2018 is nowadays, many of the companies are going forward with a concept called as model-based definition. In model-based definition, we are going to give the dimensions, dimensional tolerances, geometrical tolerance, all the requirements in a 3D model itself, and then import that 3D model into a manufacturing system, a CNC machine, sophisticated CNC machine. And then the CNC machine is capable of reading the 3D model and then produce the part. Okay, so 2018 focuses on how to give GD&T symbols on a 2D drawing as well as 3D models so that it is compatible with the latest CNC machines and measuring equipments. Okay, this is one or two major things. There are other changes which are minor changes. So two important changes is focusing on model-based definition and two symbols being deleted. Second question, what I have in the list is, sir, in nowadays, why we are not using concentricity and symmetricity? That was one of the reason why it was deleted from 2018. Okay, so concentricity and symmetricity are feature controls wherein there is a bit difficulty in inspecting that and then validating the part. One of the easiest way of achieving concentricity and symmetricity is to use positional tolerance. So many people started using positional tolerance. Another advantage of using positional tolerance is it is a feature of size control, we call it. As I told, concentricity and symmetricity are feature controls. Position is a feature of size control, which means in one of the class, Josh was explaining about maximum material condition modifier being used to get bonus tolerance. So with concentricity and symmetricity, we cannot use maximum material condition modifier according to ASME standard. So that is allowed only with position. Many people started using position and concentricity, symmetricity had very less importance. So ASME committee took a decision to delete those two symbols. So I think whatever I explained will answer the third question. Why two symbols deleted, right? Yeah. So there were three questions. I have answered all the three questions. Any other question? What is the difference between concentricity and coaxiality? According to ASME, there is no difference between concentricity and coaxiality. They are the same, but yeah, according to there are two standards for GD&T. One is called ASME Y14.5, which was given by American Society of Mechanical Engineers. Since this is American Society of Mechanical Engineer is American body, few countries did not want to follow it. So they formed an organization called ISO, and in ISO also we have GD&T, but in ISO we don't call it as GD&T, but we call it as GPS, Geometric Product Specification. In Geometric Product Specification, the standard number is ISO GPS 1101. There we have two terms, concentricity and coaxiality. Concentricity means two centers aligned in one axis. Coaxiality means two axes aligned to one axis. Axis to axis alignment is usually called as coaxiality. Usually this term would be used for one hole to another hole axis alignment. Concentricity is center to center alignment. Usually it would be used for shafts, stepped shafts, two different diameter shafts. If you want to align one center of the shaft to another center of the shaft, we use concentricity. Okay, so next is in some drawing, multiple datums are used. In that case, can we use any three perpendicular features for alignment? I think that this was explained by Joshua in one of the session, Joshua Tamil Parati. So you cannot choose your own perpendicular features for alignment. In a feature control frame, third, fourth, and fifth compartment are important for us. Whatever comes in the third compartment, that should be the first feature for alignment. Second, in the fourth compartment, what you have is called as a second datum, which is a second feature important for alignment. And in the fifth compartment datum, what we have is called as tertiary datum, third datum. That should be the third surface which you have to take for alignment. So when you take those three datums which are identified in the feature control frame as datum references, you will get three mutually perpendicular planes, and that plane is called as datum reference frame. Okay, so I'm just explaining it orally because of there are a few more questions. Maybe after finishing these questions, for this multiple datums, I can take some example and then explain it to you. How material modifiers will use in manufacturing? If I can reframe this question, if your question is how material condition modifiers are going to be useful for manufacturing, then whenever we use modifiers, we'll get extra tolerance called bonus tolerance. When we give additional tolerance to the manufacturer, then he will relax in his manufacturing processes, because of which the cost of manufacturing would reduce. If your question is how to use modifiers, then that is a very big explanation. We have to take it up in a different forum. Okay, the next question what we have is, sir, in drawing, which dimension should we prefer to provide datums? Usually for datums, we don't require any dimensions. Any feature can be identified as a datum because datum is a reference. So it can be a feature, it can be a whole axis, or it can be a center plane of a slot. Many types of datums are there. Whatever datums can be required for that particular application would be taken as a datum. What is the meaning of true position? Or I don't understand the question. WHT is mean true position, and below you have written as true position formula. There is no formula for true position, but there is a formula for fixed fastener and floating fastener. Whenever we assemble two parts together, then there are two types of assembly that are possible. Whenever we have clearance hole in both the parts, then we call that as floating fastener. And whenever one of the part is having threaded hole and the other hole as a free hole, then we call that as fixed fastener. So for that we have formula, but not for true position. Composite tolerance is quite much more advanced level of GD&T. I don't think for basics at this point of time, let's not worry about composite tolerance. Explain projected tolerance. So explaining projected tolerance would again take time. Let me check with the team if we have some time to explain that. We have so many questions popping up, running around. Sir, can you explain projected tolerance zone modifier? So again, there is another person who is asking about projected tolerance zone modifier. Okay. Still my screen is visible, right, team?
Yes, sir.
Okay. Now, let us take one example. We have a part like this. There is one hole this side and another hole this side. I want to assemble a pin. This is my assembly and functional requirement. Okay. But what can happen is because of manufacturing difficulty and so many other constraints, we may end up getting a part like this. This hole slightly tilted, and this tilt would be within the positional tolerance that is given in the drawing. And this hole is like this. Okay. Now, if I try to assemble a pin, that pin will trace a path like this. I will not be able to assemble the part. So in such conditions, we use this particular concept called as projected tolerance zone, wherein we project the tolerance zone outside the material so that this tilt, whatever tilt that you're seeing here, this tilt can be reduced, and then you will be able to assemble the pin into the part easily. So the method of reducing this tilt is projected tolerance zone. So for today, I think this is sufficient. If you want to know how to use that and how to reduce that tilt, then it would take some more time for me to explain. We'll take it up in some other day. Okay, true position means the theoretical, whatever I had explained over here. My requirement is this. So whatever I give in the drawing, I tell this hole should be at so and so height, right? So from this surface to the center of this hole, I give some dimension, say 50 mm. It should be exactly 50. That 50 is called true position, but practically achieving that 50 would be difficult. So that is how we got this variation. Okay, true position is the theoretical value that we give in the drawing. In the drawing, the threaded hole call out MMC. During inspection, some inspector gives MMC, some inspector not giving MMC. Which one is correct? Inspection method. MMC is not given by the inspector, MMC is given by the designer. Okay, so whenever designer gives MMC in a drawing, then there is some extra tolerance available for the manufacturer and for the inspector. So they have to utilize that extra tolerance for manufacturing and inspection. Regarding multiple datums, what if ABC are not perpendicular to each other? I have seen in some drawing ABC are perpendicular, AB are perpendicular to C is not perpendicular. Yeah, in that case also it is possible to make them perpendicular. Say for example, you have a part like this. If you see the side view, it would be a thick plate like this. I can take this as a datum A, this as datum B. Now, according to your question, these two are perpendicular. A and B are perpendicular. Now, if I take this as the third datum, C is not perpendicular to B, but it is perpendicular to A. And if I want to make a hole over here, I can take a positional tolerance and give A, B, C as the datums. Now, what is the meaning of this is, this plane will intersect this B datum. At the point of intersection, you can create one plane. This plane is perpendicular to B and it is perpendicular to A. So on the drawing, this is not perpendicular, but on the fixture, you can make it perpendicular. So this will become your reference. From here, how far is the hole? That can be made or measured. So datums need not be perpendicular to each other. Using those datums, we have to create a datum reference frame which are mutually perpendicular to each other. That is the concept of datum reference frame. Okay. What is the rules in GD&T? There are two types of rules. One set of rules are called as fundamental rules. Another set of rules are called as general rules. I don't know which rule you are talking about. If it is general rules, in general rules, there are two rules. Rule number 1 and rule number 2. Rule number 1 is simply tells that whenever we give size tolerance, that size tolerance will also control form. If you remember, when I started with my presentation, I told that there are 4 descriptions that we have to give: size, form, orientation, and location. So whenever we give plus or minus dimensional tolerance, that is not only going to control the size, it will also control the shape. That is rule 1. The second rule is called rule number 2, which tells that when you don't give any material condition modifier, by default, regardless of feature size applies. So only when you know these terminologies, what is regardless of feature size, when to use regardless of feature size, only then you will be able to understand rule 2. So can you explain tolerance stack-up analysis? We are in a GD&T discussion, so let's not worry about tolerance stack-up analysis. Maybe if it is in a different class, we will discuss. It's a very big topic to discuss. Tertiary datum means the third datum, whatever you give in a feature control frame. So here I have given A, B, and C. This C datum is called as tertiary datum, third datum. If I use only one A, then it is primary. If I use B, then A and B, primary and secondary. If I use the third one is tertiary. Okay. First rule of GD&T is rule number 1. As I told, it will control the size as well as form. Let us say that I have a part with 25 plus or minus 1 mm. Now this plus or minus 1 mm is given for size control. But along with size, we are going to control the form also. So in one of the class, Joshua was explaining about form. What are the form controls that we have? Straightness, flatness, circularity, and cylindricity. So here what we have is a prismatic part, plane surfaces. So I can end up getting a part like this, right? Now what is this error called? Flatness error. So this size should not be more than 26. This size should not be less than 24. And the surfaces within these two sizes. So because of which flatness is being controlled. Now in this particular case, the flatness error, maximum flatness error the part can have is 2 mm. This is what rule 1 tells. Now, if I want to have a better flatness control than what I get out of this size, dimension, and tolerances, then we have to give GD&T. So I have to give flatness on the surface to control this, to minimize this. Sir, I just joined now. Can you please brief it out? I am sorry. Joining late is not acceptable. You know that this one is already scheduled between 8 to 8:30. So you should have joined. You should have some discipline, my dear. So don't expect me to repeat the whole thing again. Okay. How to check position with respect to datum A? This is a very big topic. I think Tamil Parthi and Joshua team will explain you in a different class. In first session I am attending. This is my first session I am attending. So can you send me previous session recordings? Okay, already the links are being put over there, so you can. I think whatever. What is form tolerance? So here, form tolerance is nothing but straightness, flatness, circularity, and cylindricity. So any of these four errors are called as form tolerance. Yes, of course, you will get the recordings in the YouTube, and UMS team would share you the link after this. How to check tertiary datum? Tertiary datum is not for checking. You have to use that datum to control something else. So always datums are references. It is not for checking. Of course, you have to control that and then check it. But after controlling, you have to use that. Tertiary datum is something you're going to use it for controlling something else. You watch the video, you'll get to know what all the points that we have discussed. As I told you a few minutes before, after this video would be shared in the YouTube and the link would be available for you. If you watch the videos, you will get to know the points that we have discussed so far. I think we are done with most of the questions. Datums cannot have high deviations because, as I told you a few minutes before, if we take a datum, that a datum should be controlled with some GD&T, and the error should be within that limit that is specified. So it will not have high deviation. If it is having high deviation, we cannot take that as a datum, first of all. What is a circular runout and what is the difference between circular runout and total runout was explained in the previous session by Joshua. You please watch that video. You will get to know the difference over there. The innermost diameter, if you're referring to a hole, and if that hole is independent, then you have to give cylindricity, not circularity. If that hole is dependent on outside diameter, then you have to give position. As I told, concentricity is deleted. So better option to control is position or total runout. So cylindricity if it is individual feature, position or total runout if it is related feature. Datums should be established based on how the part is going to get assembled and what is the functional requirement. Say for example, there is a part like this. There is another part like this. I want to assemble these two parts together. Now, this is the surface that is going to enter into the hole first. So this surface would be considered as individual feature. If it is individual feature, what we can control is only form. So in form, as we already discussed, we have straightness, flatness, circularity, and cylindricity. Out of these four control, for this particular surface, more appropriate is to use cylindricity. So I control this with cylindricity, and then I take that as datum. Now this surface, whatever we have here, is maintaining 90 degrees with the axis. So for this surface, I can give perpendicularity. Like this, we have to establish datums. Right? So I control one feature, then take that as a datum. With reference to that datum, I control this. Now suppose there is a hole here. Then I have to take this as another datum. I can give positional tolerance to this with reference to datum A and datum B. Like this, step by step, we have to establish it. Which thumb rule you are talking of, I am not sure. So I will not be able to answer this question until I know which thumb rule you are talking about. I think we are overdue with the time and it's time for closing. Over to EMS team, you can conclude.
Yeah, good evening. Myself, Tamil Pardi. First of all, I would like to thank Mr. Palaniyappan Kailashan sir for an excellent dynamic conversation with us. And I would want to thank everyone who attended this webinar. And I would like to inform you that we have a SkillMac community group on WhatsApp. Please scan the QR code to join the group. We will give updates through this group on the next class topics, date, times, and meeting links that we will address in the future. And upcoming week, we are going to cover plenty of interesting quality topics like 7QC tools, SPC, MSA, 8D principle, Six Sigma, and lean manufacturing, and some kind of measurement techniques in CMM, VMS, contour roughness, portable CMM laser tracker, and by using 3D laser scan. And also we offer offline training program with hands-on experience at our Bangalore site. So please get in touch with us. It will help to reach you from ordinary to extraordinary person. Please use QR code to write your feedback. Once again, thank you all for your great support. Thank you so much.
Using this QR code, you can join in our WhatsApp community. So we'll be updating topics in upcoming. We have planned new topics